this, right? That's how I feel like every comedy show starts in every city. Okay, so today we're going to be talking about clinical reporting with this package gtsummary, and primarily what's going to be coming around the whole point of this is making high quality and reproducible reports. And I'm going to be coming to you from the perspective of a medical researcher. So like Mary mentioned, I'm a biostatistician at Sloan Kettering. So in my role there, I supervise a small team of statisticians, and we do a ton of collaborative work with the urology department, primarily at our hospital, but also collaborators all over the world. And what we've done in the beginning was that my group was a Stata shop. I know, like curse words at our meetup, but that's just the way it was historically when I arrived. So I had to learn Stata when I got there, and it was fine for many, many years. And I'll tell you about our evolution into R and R Markdown. So the slides that we're going to be reviewing today were actually a workshop that we gave at the R Medicine conference back in August. So, and that's a wonderful conference if you're not familiar with it. I'm a co-organizer for next year, so please come. We'll have lots of lovely speakers. Many of them could be you if you submit an abstract. I would love to read those abstracts. And so the workshop was actually a bit longer than the time we have here. So we're just going to go through this at our own pace, and might skip a few little sections here and there that aren't the most important, I feel. But I just want to reiterate that that recording from the workshop, which was again 3 hours, is available on the R Medicine website. So to get more out of this meetup, I would really strongly encourage you to interrupt me as much as possible and make this a conversation, and we can ask questions, answer questions, talk to each other, make sure that we all have a good understanding of what we're discussing here. So I guess we shall get started. So again, this was at R Medicine. I'll skip this because Mary did some fantastic introduction already. And let's talk about the motivation. So my group, like I said, was a Stata shop. So we were all Stata. We wrote all of these Stata functions and programs to try to make our work reproducible. And how we used to do that, it's like so embarrassing thinking about it. But this is like more than 10 years ago. So we would write these functions to like pass it like a model object, and then it would print into the console, like the rounded coefficients, for example, and it would separate the different columns of a table with ampersands, and then we would copy it out of the console, go to a Word document, paste it in, convert that text into a table, and we were like patting ourselves on the back. We are so reproducible. We don't copy and paste individual numbers from the console. We do it a whole table at a time, so which I don't, that was good for the time. But when we saw that our Markdown was becoming really a super fantastic tool, we knew it was time to make the switch. And so that's what we ended up doing. And you may be familiar with the reproducibility crisis in medicine. It is very well known, very well documented. I think that there's a very famous statistician, Doug Altman, and I think he wrote a paper like in '92 called something along the lines of the scandal of low quality research in the medical field, something along those lines. And while the arc of like bad reproducibility and bad behavior in research is long, we're going to focus primarily on our part as analysts, data scientists, statisticians, whatever you like to call yourself. So some of those things that we do that are bad would be running a model, looking at the results, and copying in odds ratios to a report. Because you're going to have to probably do that more than once for the exact same project. And I know that I do approximately 100 times more checking the first time I do something as opposed to the 5th time I do something. So being able to automate and make things super reproducible is an incredibly important thing for a goal for us to have. So in that vein, we started writing the gtsummary package. So full confession here is that we started writing gtsummary I didn't actually know how to program in R when I started writing it. I just knew that R Markdown was awesome and was super, super helpful for reproducibility and quality research. And I knew we had to make the change, but we had all of those like bad functions in the Stata that we had already written. And so I knew I needed to get something up and running that was similar to that so that we could make the switch, because the whole point was to do reproducible science. And if we didn't have like a good way to make tables out of our results, for example, that wasn't going to be a good switch for us to make. So we just started writing. It's been through quite a few iterations, actually, early on. Like there's been a couple like burn down, write it over again to make it better, but it's very stable now with hundreds of thousands of downloads all over the world. So you're good to trust it, in my opinion. So what does gtsummary do? So primarily we're going to focus on tables, and so we're going to make table 1 type. So in a medical paper, the table 1 is the table that describes the cohort of the population you're working with. We're going to do cross tabulations, summaries of regression models, summaries of survival and survey data, and we're going to talk about like custom reporting. And another important part of reproducibility is when you're actually writing the prose to describe and summarize what you've done. You have to often report the odds ratios, the means, the standard deviations, the p-values from all your tables in the text of the reports that you're writing. So we write reports for to be published in medical journals, and so that's exactly what we need to do. And to make that reproducible, we wrote something called for inline text reporting. So you can report any number from a gtsummary table, inline text, formatted, gorgeous, simple call. It's really super helpful. Any gtsummary table can be stacked or merged with any other gtsummary table, regardless of the type it is. And then you can also print gtsummary tables with GT, which is what it was like made for, intended for, but also as GT is growing and becoming much better at all the output formats, we did write functionality for flex table, hux table, cable extra, cable, and also just straight up tables. And we did that because sometimes you needed Word output, but GT didn't fully support Word at that time. So we'll talk a bit about the print engines too, and all the customization you can achieve through using various ones. All right. So now we're going to get started with examples. So primarily what we're going to do here today is just go through the most common types of tables that I create in my job as a statistician, and we're going to talk about how we can tweak those tables to meet exactly how you like it, or exactly how JAMA likes it, or how the New England Journal wants it, or whatever field you're in, whatever those journals, however they like it. So we're going to start with a data set here called the trial data set. It's found inside the gtsummary package, and it's simulated data from 200 patients. About half of them received drug A, the other half received drug B. And importantly, each one of these columns in this data frame have been assigned a label from using the labeled package. All that really is just an attribute to the column, and the attribute is called label. And these are super fantastic and super helpful if you're not already using labeled data. I love them. And gtsummary is able to take advantage of those labels and make your tables like one line of code, you can publish a table. It's so easy. So we'll talk a little bit about that. I think that's something that Crystal knows a lot about, likely far more than me, actually. So before we move on, so you can see here the table on the right, we have a column TRT, which is the treatment. We have their age. We have some marker value, the patient's cancer stage, their grade, whether or not they responded to treatment, 0, 1 for yes and no, same for death, and then also time to death. So we're going to do a little bit of survival analysis if we have time. Oh, there's something really loud going on. Oh, do you know what it is? It is my son going to bed, and the baby monitor's on. So let me go turn that off. Just a second. I was like, who is singing Old MacDonald over here?
Yeah, I'll pause it. No problem.
Apologies. Thank you.
All good. Yeah.
All right, so the trial data set, we're going to primarily focus on a smaller version. So we're going to call it SM trial for small. And it's just going to have treatment, age, grade, and response. And it's just a little bit more contained, a little bit easier to go through the examples with. So, all right, again, if you have questions, 100% feel free to stop me. So when I gave this as a workshop, we had exercises throughout, but we're going to do them all at the end if you have time, if we all have time. So let's start with the most widely used function in the gtsummary package. It's called table summary, TBL summary, and it creates summaries of data frames. So let's just show you the most basic usage here. So you can see on the left here, we're taking that small trial data frame. We are piping it into a select statement. And we are deselecting the treatment column, and then we're piping that data frame into TBL summary, and you can get a nice table here. So how did we get a nice table without telling TBL summary anything about our data? So you can see the first column here, the first row here, age. We're reporting the median and the interquartile range. So what TBL summary did, it said, okay, well, you haven't told me what to do with age, so I'm just going to do my best to guess. So I see age has a lot of unique values, it's numeric, and it has some spread to it. So I think this is a continuous variable, so I'm going to summarize it continuously. Moreover, I can see that like the spread is pretty large. So I think that rounding age to the nearest integer is going to be sufficient precision for this variable. So it uses all sorts of heuristics to kind of just make a good guess. And like about 90, in my own experience, like 99% of the time, it's exactly what I want. So that's great. You can see below here, grade. It recognized that. I think grade is a factor or a character. I think it's a factor. So it obviously knew this is a factor. It's not continuous. So it presented it here categorically. And then response, so tumor response is the label. You can see that that's actually presented on one row instead of multiple rows like grade. So the difference here is that tumor response is coded as 0, 1. And it recognized that, hey, you know, this is a 0, 1 variable, which is a very common way for representing like binary data, like did you respond yes or no? And so it's just going to say, I think that's dichotomous data. I'm going to put that on one row. And there's a couple other features here that you see. Instead of saying age, like the variable lowercase age, that's the variable name, it's capital A, age, and same for grade. And for response, the column name, you see tumor response. Those are the column labels that are being utilized. So that's a good reason in my book to just label your data, because you can get a really nice table with no work. I mean, like, when can you get a table like this in one line of code? Okay, so now we're going to need to customize it a bit. So, you know, in our line of work, we're often comparing 2 or more treatment groups. So right away, we're going to, over here, we are going to say, please submit, prepare all of these summary results by TRT, right? So that's what we get in the end. Treatment A, treatment B, the same table you saw previously. And you can do any number of levels there. There's like there's a few other packages out there that will like say, oh, I can only do up to 4 groups, but this is unlimited. And so now we're adding the type argument. So we saw in the previous iteration, the previous table, the previous slide, that age was summarized as a continuous variable. There's actually 2 types of continuous variables in gtsummary. So the first puts it all in one line, like what we saw previously. And the second is continuous 2, which presents things on 2 or more lines. So you'll see a lot of this kind of reporting in like the pharmaceutical industry, where it will be like number of non-missing observations, the mean and the standard deviation, the median, the IQR, the range, the number of missing values. So it's like a lot of rows for one variable. So here I'm saying, please make age continuous 2, meaning put it on 2 or more rows. And you can see here on the right now that age is still using the same default statistic, which is median IQR, but now it's on the row below age, and you have that there. So you could also modify that to give us, like I said, mean and standard deviation on another row, the min and the max on another row, you know, what have you. So that's how you can specify or change the default types, the summary types of variables in gtsummary. So now here we're going to modify the default statistics. So like you saw previously, the default was median IQR, but here I'm telling it, instead of the mean and the median IQR for age, I'd like to see the median and the standard deviation, and then also the min and the max. for my response variable, please add the denominator. So to make it very explicit what this binary variable is out of. So you can see on the right that those are the changes that have been made. We're going to further change the default label. So previously it was grade only, I think, and now we're saying pathologic tumor grade to be very precise about when this grading of the tumor occurred. So just to illustrate that you can change these defaults quite simply. Now, previously you saw age was rounded to the nearest integer, and now here I am with the digits argument saying please specify this to the nearest 10th the 10th place. So we're getting one more decimal point of precision here. So a little bit about how gtsummary works with formulas and selecting variables. So gtsummary supports all of the tidy select syntax that you're likely familiar with already, found throughout the tidyverse, and dplyr and tidyr and whatever. So just very generally, you can pass formulas. The left-hand side of the formula is the selecting variable bit, and on the right-hand side of the formula is the instructions that you want to apply to the variables you selected. So in this first example, I'm saying, oh, I want to label age as patient age. And then for the next one, I'm saying, please take the columns age and marker and make those continuous. You can see that we can use the tidy select selectors, like starts with, ends with, matches, contains, all of them work here. So this one says starts with age, and I want to summarize that to 0 decimal places. And then lastly, there are these custom gtsummary selectors that are meant to help you select groups of variables within a gtsummary table. So all underscore continuous is going to select all of the continuous variables. So that's very helpful when you, rather than reporting the median IQR, you want to report the mean and standard deviation for every single continuous variable in your table. So you can just do that in one line rather than saying, age, do this, markers, do this, keep on going and going, because it can be quite a few. And whenever you need to pass like more than one set of instructions for a specific argument, you can just slap those into a list. So you can see here, label, we can say age tilde patient age, comma, marker tilde marker level. So what's actually happening in the background when you pass a list that looks like that, it's being converted to a simple named list. So you can actually just pass that named list if that is preferable for you, because there's lots of situations where I'm constructing these arguments, and a named list is actually much easier to work with. Are there any questions on this syntax? This syntax is used throughout the package.
Yeah, the only question we had, which I think we answered, someone said, is continuous variable the same as numeric? And like, how are you using the term continuous here?
Okay, so it's not exactly numeric because like a 0, 1 variable, we assume that that's dichotomous, although that's numeric. And also, if your numeric variable has very, very few unique levels, then we might, if it's very few, we will assume that that's actually meant to be categorical. So like the most common example that I can give is in the MT cars data set, there is a column called CYL. It's for the number of cylinders in the car. I have no idea what that means, but it only has 3 levels. So if you were to pass MT cars to TBL summary, it would look at that CYL column and be like, okay, well, it's numeric, so it could be continuous, but it only has 3 unique levels. So I'm just going to guess that it is actually categorical.
Can I just ask the follow-up question?
Yeah.
It's really helpful. So if, let's say, if you do have that type of like a cylinder number variable in your data, is there a way I can force the program to decide either option, or it's always going to be automatic guess?
No, yeah, it definitely, I think we make very reasonable guesses, but you can definitely change anything. So here in this type argument, age was defaulted to continuous, regular continuous, not continuous 2, but we override our default by saying make age continuous 2. So in this example, if you wanted CYL to be summarized continuously instead of categorically, you would say CYL tilde continuous, and that would change the default type.
Okay, thank you very much.
No, thank you for asking a question. Okay, so one lovely thing about gtsummary is that the functions can stack on top of one another. And I think this actually makes it quite powerful and quite extendable as well. So there's this class of add underscore functions that are going to add additional information, like additional columns of statistics. So you can add p-values, q-values, overall statistics, treatment differences, number of observations, and many, many more things. So you're going to see, we're going to introduce you to some of these add family of functions. There's another family called modify. So modify are actually ways to modify the aesthetics or the attributes of a table that you're going to create. So use the modify family to change default headers, spanning headers, footnotes, and a whole lot of other things, but those are the most common ones. These bold and italicized functions, they style things, so they actually kind of belong in modify a little bit, but we gave them their own names because they were so commonly used. So let's go over some examples. So you can see here on the left that we started with our basic TBL summary that's been split by treatment, okay? And we are piping that TBL summary object into add P. And you can see that a new p-value column has appeared. And then we're piping that into add q, and we're choosing the method of false discovery rate for a correction for multiple testing. So let's focus on add p for a moment. When you look at the p-value column, we see that we are now comparing age between treatment A from drug A and drug B, okay? But the question is like, well, how did you compare them? So it has a footnote. If you go look down at number 2, it's saying, okay, Wilcoxon rank sum test. Okay, that's actually very helpful. If you continue down the line, you can see grade has also been compared between drug A and drug B. But you know that you can't use Wilcoxon rank sum test on grade. So you can look in the footnote and say, okay, well, Pearson's chi-square, that one probably goes with age, and similarly for response. So the footnotes will tell you explicitly what is actually happening in the background, which is quite helpful. Add Q, when you run add Q, I like one thing that it does is that whenever you use someone else's package, do you get nervous that when they say they're doing something, that means the exact same thing that you think it means? Because like every field is a little bit different. Like one example that always catches me is like, when you say marginal effect, do you mean conditional effect? And what do you think conditional effect means versus marginal effect? Because I feel like these words are just thrown around, and some people are very precise. Some people are just like, whatever, I'll just tell you what I mean. And I'm more the second type. So one thing that happens when you run add q, it's running the base R function p.adjust to adjust for multiple comparisons. And it's actually going to print the code that it's actually using to calculate those adjusted p-values. So there's no ambiguity about exactly what's happening there in the background. And even if there were, the help file is very descriptive, and there's a p-value saying I've done false discovery rate for multiple testing. So I think that's some pretty wonderful features of the package. So, I mean, even this table right here, we've made some pretty good modifications. We've added some pretty useful information, some things that are like appearing all the time in medical research. And so that's pretty great that you can do this in just a couple lines of code. And it's like this table is like ready for publication in a journal. Let's just review a few other functions you may want to. Oh, Yolanda.
It looks like you have a question. Yeah.
Yes. Hi.
Hi.
I have a question. So when you're calculating the p-values, you are specifying the test that you're using. So if here you are reporting the median and interquartile range, but if you were reporting the mean, you will be that would be compared using t-test. Say if the proportions here were like something that the chi-square was not the correct test, would it do Fisher exact or something like that? And it will tell me, and it will decide.
Yeah. Oh, so that's a fantastic comment. So thank you very much for that question. So yeah, there are some different behavior that that can be made based off of your data. So yes, if you have very low cell counts or expected cell counts below 5, I believe the threshold is, it will update from chi-squares test to the Fisher exact test. So that will happen automatically. In this case, if you present the mean versus the median, we're still actually just going to default to the Wilcoxon rank sum test, but it's going to be listed here. But you can definitely, absolutely change the default tests. And there are, I think, probably maybe 50 common tests available, and they're documented on the website as well. And so you can see every test that is available to you.
Great, thank you.
Thank you for the question. I appreciate it. Okay, couple other examples of our add functions. So again, we are splitting this table by treatment, but sometimes you need to see everything overall for all the cohorts combined or all the stratum combined. So there's an add overall that's essentially running a TBL summary in the background, just not stratified by treatment, and then kind of just putting those tables together for us. So that's a pretty common and useful function. Add n will add a column with by default, the number of non-missing observations. So, we see some journals present data like this. So we just wanted to add a function to make it easy for anyone who publishes in a field that requires tables like this. And you can see here that in TBL summary, in the call over here on the left, we did add missing equals no. What that means is that instead of putting a new row for the number of unknown observations, we're omitting that. But that's okay in this case because we're adding that column n to show how many non-missing observations we have. Add stat label. Okay, let me show you this table first. Take a look at the footnote. It's saying we're doing the median IQR in the footnote and the n%. I run this function add stat label. The footnote disappears, but what appears is the median IQR in the label next to age, the number percent, and the number percent for the for the categorical and dichotomous variables as well. So this is a common format you'll see in JAMA and a few other journals as well. And just to round it out, some bolding and italicizing. You can bold the labels, you can italicize the levels or bold them as well. You can bold significant p-values. The threshold default is bolded if it's less than 0.05, but I had to increase the threshold to 0.8 to actually get something to bold in this table, because many years ago when I simulated this data set, I really should have put some stronger relationships in here, but it is what it is. It's too late to change, I feel. So anyway, cute ways to style your tables, I think. And I think this is good to see, but you maybe can't memorize it right now because it's a lot to take in. But modify header will change the header. So the default is to show the drug A, drug B with the number in each group. And here I'm changing it to group A, group B, and I'm adding a spanning header that says the drug, and I'm adding a footnote for the statistics that are presented, and I'm just showing a little bit different statistic that is it's the same information but just presented somewhat differently. So you may be looking at that code on the left being like, well, how did I know that stat _1 was the first column and stat _2 was the second column? There's a function called show header names that will just show you, okay, this is what the underlying column is, and this is what the current label is. And so it makes it much easier to identify which columns you may or may want to change. There's another helper function that was similar to all continuous that you saw previously called all stat calls. And what that's going to do, it's going to select all of these columns that are summarizing statistics. So that's a nice way to add a quick spanning header over all of the group A, and group B. And this is what you're going to get when you run show header names. You're going to get the column name on the left and then the header value on the right. So you can easily see which columns you want to modify, and all stat calls is going to select those stat columns. All right, so we're kind of flying through this, and I hope that you're gleaning something from it. But again, please ask questions as needed. The add difference function is one of my very favorite functions. I just love it so much. Instead of just adding a p-value, it adds the difference between two groups, and the difference is confidence interval, and the p-value comparing the two groups. And it tells you exactly what it did to compare them. So this is super, super helpful because I am constantly comparing two groups, like these patients receive this drug and these patients receive that drug. Which ones do better? It's a very, very common task in research, right? So, and just to, as an FYI, the add-p, the add difference functions, there's all sorts of tests available to you. It can handle correlated data. So if you need to do p-values and differences that are calculated from, for example, like a random effects model, that model is pre-built into gtsummary, so it's easy to use. Okay, and there's one last function called add stat, which is like very, very general, and you can add any custom statistic. It's actually used quite heavily in the background to construct helpers like add p, add difference. So just FYI, there's other functions. You can make your own custom functions. It's all there. It's the documentation is actually really thorough. I think we spent a lot of time on the documentation on the website, so please check it out. All right, I'm going to go through just quickly a couple of other things that you can do. So there's a function called TBL cross, which does cross tabulations. This is actually just a simple wrapper for TBL summary, but highlighted specifically to give you results that look like a typical cross tabulation. And you can see here that add p is actually a generic function, and it has S3 methods for TBL cross, for TBL summary, and other functions that we're going to see in the future. And so, and you can see here that instead of adding a new column for p-value, you can say, okay, can you actually just add this as a source note instead of a new column? And you can see that it appears down here, looking like a footnote. You can bold the labels if you'd like, just like the other tables as well. There's a function called TBL continuous, also a wrapper around the summary tables, and you get a categorical variable on top and on bottom, excuse me, on the left and on top, and the contents of the cells are continuous summaries. So in this case, it's variable age. So those are the median IQR of age for drug A in stage 1, for example, right here in this. If you work with survey data, there's a TBL survey summary, and it takes survey design objects, and it does exactly the same stuff, same everything. So it's pretty wonderful. And if you work with survival data, probably fewer of you do, then you can also summarize Kaplan-Meier or product limit estimators as well. Okay, summary tables, that was a huge amount of information, and I do hear that I'm flying through it. So any questions before we move on to regression models?
I have a question. Hi, Yolanda again.
Hi.
Where you omit the missing values, where you say, I think it's missing equal no or something.
Yeah.
Yes, that's a global table, so it will eliminate all the missing information for the whole table. I don't know why would anybody want to do that, but could you say I wanted to keep the missings for age, but not for the other variables? Can I do that?
Yes, you can. So how you would do that is you would keep the default missing equals any. So if there are missing values, for example, for age or for tumor response, they will appear. But if you needed to remove the row that says unknown just for age, for example, there is a function called remove row type. And you can say remove the missing row for age, or you can say remove the missing row for all the variables, or only for categorical, or only for continuous. So so whatever your situation is, yeah, you can make that work. But
okay,
we don't cover that function here because there's already like so many functions that we're talking about. But one important thing I did realize that I forgot to mention is when we changed the default statistic from median IQR to mean standard deviation right here on the left, we're using curly brackets here. So this is also used throughout the package, the glue syntax. If you haven't used the glue package or the string R package, which has a function called str glue, it is super fantastic, and I hope you read up on it a little bit. It's very straightforward and a wonderful function and package. So what essentially happens is that anything in curly brackets is going to get evaluated. So when gtsummary sees this string that says curly brackets mean, and then it has in parentheses curly brackets SD, it's doing double duty. What it's doing is saying, hey, there's a function called mean, and I want you to use the mean function to calculate the means and put whatever that number is right here in this string. And so that's what it's doing. It's saying, use the mean function, put it right here in this string. So you really can customize this quite a bit. Like there are fields that are so particular about how they present their results. So I've seen people say, well, I have to report median square brackets IQR or else I can't publish this paper. It's like, okay, sounds a little strange, but whatever. And that's something you can do. So in this case, we're wrapping standard deviation in parentheses, but you could wrap it in, curly brackets even, or square brackets, what have you. All right, anything else before we get to regression models? All right. So, I'm a statistician. I love a good regression model just as much as the next person. But what I do not love is base R output of regression models. So this is messy, and I have a particular I don't know what happened to me. Maybe when I was young in life there were like too many stars somewhere, but I hate star notation for significant p-values. And like you get all these stars and these dots over here, and the estimate has so many levels, so much precision on the estimate, and they show your standard error, but I don't have a confidence interval when I really just want the confidence interval. Like there's a lot going on here. So we wanted a nice way to just like make this publication ready. So TBL regression. So just a quick, we define this object M1. It is a logistic regression model, meaning that our outcome is binary, yes or no, did you respond to the treatment? And on the right-hand side of the tilde here, the formula, we're doing age and stage. So we're saying, do age and stage predict response to treatment? We're using, again, the trial data set, and we're specifying the logit link to indicate that we're doing a logistic regression. So as simple and easy as it can get, the TBL regression function takes in the model object M1 that we just built, and you get the table on the right. And there, like straight out of the box, there's a lot of things I love about this table. So first, what I love is that it can go into the data, see that, I'm going to go back to the slide again, that stage has levels T2, T3, T4. It can go into the data, find the variable stage that groups T1, T2, T3, T4, and it can identify that T1 is your reference group and add the row for reference group. Also, it can indent those all together and add a header row to say these are all T stage. And again, it's grabbing the label from the data set, the data frame that you passed to the GLM function and getting that T stage label. So this is pretty awesome. This is like really close for publication ready, I think. And it was so easy to write this, not to write the function underneath, but that's expected, I think. Another cute thing I like about this function is that you'll see at the top, rather than saying something like slope or coefficient or beta, it says log OR with a footnote to say that OR stands for odds ratio. It recognizes that you have a logistic regression model, and therefore it's going to show you that you have log odds ratios by default. So to make a few common changes to this table, when I report logistic regression results, I don't want to report the log odds ratio. I want to report the odds ratio. So I'm going to say exponentiate equals true. And I'm not necessarily interested in how T2 disease does compared to T1. Rather, I'm globally concerned about, is T stage predicting my outcome at all? And so I can use the function add global P to remove the individual P values from T2, T3, T4, all comparing themselves to T1 to say, does T stage do anything at all? And I'm also piping in this function add glance table, which adds these 4 rows at the bottom. the number of observations, the log likelihood, the AIC, and the BIC. So the ACA-ICI information criteria and the Bayesian version as well. All these statistics that we're adding to the bottom, they come from the glance function from the Broom package. So there are far more statistics you could be reporting here. So it's great. Any questions about what we've seen so far with regression models? All right, so lots and lots of models are already supported. So essentially, if the Broom package has a tidier for your model type, there is a very good chance that it's supported out of the box. So there's actually likely far more model objects that are supported, but I've just never tested them because I haven't needed to. And so if that tidier exists already, that's fantastic. Use it. If it doesn't exist, the TBL regression function does have a tidy fun argument where you can write your own tidier and you can have it do whatever you need it to do. And it can be supported by the package as well. So in addition to doing a single model summary, it's not uncommon that you actually need a series of univariable regression models. So all these models have the same outcome, but you want one model for treatment predicting tumor response. You want another model for age and another model for grade. So there's a function called TBL UV regression. So instead of passing a model object, you're going to pass it the data frame. So what this is going to do is you're going to tell it, please give me a generalized linear model. I want my outcome to be the response. And I want all of these arguments to get passed to the GLM function. So in this case, family equals binomial to tell it that it's a logistic regression. And just like before, we want to exponentiate the results to get odds ratios. And you get this lovely table in the end. And how did it know to do treatment, age, and grade? What it does is it looks in the arguments to TBL UV regression, identifies all the variables that it sees there, removes them from the list of covariates, and then builds the logistic regression models, and then summarizes them, and then puts them all together in a cute little table for you. So I can tell we're flying because this is when we did our 1.5 hour break last time I did this. So, and you may recognize this from the closing credits of Sister Act 2, Back in the Habit. I can't believe it didn't sweep the Oscars that year. Okay, so still upset about it. I was in the 4th grade, I remember well. Inline text. So we touched on this in the beginning. And in addition to these lovely tables that we're making, the most obvious thing that I need to report from this table, like for example, this odds ratio for treatment for drug B versus drug A, I need to write a report and say, we compared treatments A and B, and the odds ratio was this with confidence interval this and p-value this. So that's what inline text is going to do for us. So inline text works with any GT summary table, by the way. And you can report any of the statistics from any of the tables in here. So we're going to talk mostly about regression models, because I think that's like probably the most useful bit. And so here, when you're passing a regression model or TBL regression object to inline text, there's a default pattern. And you're going to notice that where you're going to see your curly brackets, your glue syntax again here. So by default, inline text for a regression model is going to give you the estimate, that's the odds ratio, the confidence level with a lower bound and the upper bound of the confidence interval, and the p-value. All right, so let's see it in action. So if we had this table, what I would write in my markdown or quarto report is I would say the odds ratio for age is cute little backticks R, and then when you see that and it has the R followed by R, it's going to execute whatever comes next and just plop it right into your report. So if you haven't seen this before, this is a really wonderful knitter R markdown quarto feature. So I'm going to say the odds ratio for age is inline text passing the model object TBL UV reg that we saved, and I'm going to say give me the results for age. And because we have a default pattern, it's going to say when you render your report, it's going to say the odds ratio for age is 1.02, 95% confidence interval, 1.0 to 1.04, and the p-value is 0.10. This is super powerful. Like this is awesome. I do a ton of research projects and ton of publications every year. I like have hundreds of published papers, and this stuff saves me so much time because it's super frequent that we prepare a report, we're like ready for publication, and then someone will be like, wait a minute, what about those patients who received that super rare treatment that's totally not applicable to what we're talking about in this paper? I'm like, oh, when they remove the prostate and the bladder at the same time, cysto-radical prostatectomies, and they're like, yeah, do we have any of those in there? It's like, let me check, they're super rare. And I was like, oh yeah, well, in this study of 5,000 people, we do have 3 of them. And they're like, okay, let's remove them and rerun everything. And this makes sure that you don't forget to update anything. And it is super fantastic.
I have a question. What if you wanted to, instead of writing it that way as 95% confidence interval, you want it equal to, and in parentheses, the confidence interval?
Oh, yes, because we're using simple glue syntax here, there's a pattern argument in the inline text function. And so this is the default for regression models, but you could literally put anything you want here, and anything that appears in the curly brackets will just be evaluated. So if you wanted to put 95% CI equals, you would just put that little equals sign right after this, and then you'd have conf low, conf high, and then you would get that equals sign as well. So any way you want to report these statistics is possible.
Great, thank you.
Thank you for the questions. I love it a lot. So this is a lot of text for for one slide. So that's just fun. And I threw this in here because one of the exercises at the end has inline text reporting from a TBL summary table. So I just wanted to put it in there. So on the left here, we have what your code looks like. So we can say the median IQR marker among participants randomized to drug A was backticks, inline text, this little table that I'm just creating up here, by the way. Variable marker, column, drug A. So it's going to go marker, drug A, because it can recognize this, and it's going to report this business here. So, and in this one, I can see that I have a typo here because I said the median IQR age among participants randomized to drug A was, but I changed the pattern here to only report the median instead of the median IQR. So this really shouldn't say IQR right here. I apologize. So you can see here, but on the left, you can see that drug A was 0.84. So there we go. It's all very cute. And then the same down here, you can change the pattern for the, to get, this has a difference of 0.20 with a confidence interval and a p-value. And so you can say the difference in marker levels was inline text, GT summary table, variable marker, pattern, give me that difference estimate plus the confidence interval. And you can say that over here, the difference in the marker level was 0.20, 95% confidence interval, negative 0.05 to 0.44. So reference this if you need it in the future. It's a lot to remember. Okay, so I think you may be thinking to yourself, I've seen other packages that can do that. Why? What's special about GT summary? And like, there's a lot because I gave a lot of love towards building it. Number one. Number two, it's so customizable, and I think it's so easy to customize. So in my field, and likely in many of your fields, we have just shown you how to create a bunch of like simple tables that kind of like have one purpose. But it's not uncommon that I need a regression table with a bunch of summary statistics for the variables that are going into the regression model right next to it. And then I want to do this for time to death, but I also need tables for to describe time to recurrence of the cancer. Also, another one talking about response, yes or no. So these are all kind of getting at the same thing, and they might end up being better presented in one big table that's either like stacked longer or just merged together side by side. And so that's what TBL merge and TBL stack can do. So these functions work again with any GT summary table, anything. And you can see on the right here, we're using TBL UV regression to make a univariable table of regression model estimates. And then on the right side, and these are Cox models, so we're modeling time to death after treatment. And on the right, we're still doing the same time to death outcome, but we're doing age and grade as a multivariable model instead of a univariable model. So the results end up looking quite similar to one another on the bottom here. The hazard ratios, however, are a little bit different because of the differences in the way they're modeled. So I think you might know where this is going. We're going to put them side by side because I need my univariable results, then my multivariable results right on the other side of it. So here I am with TBL merge. I plop both of my tables into a list and I say, hey, give me these as my tab spanners. And we're using markdown syntax for bolding here, by the way. And you get this lovely little table at the end. And like I said, these functions, TBL merge and TBL stack, they work with any gtsummary table. So it's really, really convenient to be able to like cobble together or patch together really complex tables from very simple components.
Can I
So,
ask you a question?
yes, please.
So assume that you have more variables here that you have in this univariate, and some of them are not significant, and you put them in a multivariate model, or you either just keep the ones that were significant in the univariate, or you use stepwise as something, and you end up with a smaller table in the multivariate. You still can merge them?
Yeah, you absolutely can. So in that case, if your variables appear, for example, using this case, in the univariable side of the table, but not in the multivariable side, the multivariable side will just have blank rows where those variables do not appear. And just as an additional FYI, the sorting that is found in the first table that's passed, so in this case, the univariable table, that is what's going to take precedent. So if you might have to rearrange that if you want them, like, for example, all of your significant p-values to appear on top, and then then the bottom half of the multivariable table could be blank, for example. So the ordering of the variables is determined by the first table that is presented or passed to the function.
Okay, thank you.
So here we go through another very similar example where we're doing a univariable and a multivariable table, and you can see here that we're building the same Cox model. We have actually more variables here than we've shown in the past. But what we're doing is we're doing two new things. We are using this show single row argument. So that's any variable that is binary can be presented on a single row when by default it might have a header row plus the reference row plus the actual estimate of the coefficient. That can be a lot of white space in some cases when it's like very obvious what the reference group is. So in this case, we are saying, oh, please put treatment on one row instead of 3 rows. And then we're saying include treat. So even though there are treatment, grade, stage, and marker in this model, because I'm saying include treatment only the treatment variable is going into the into the final table that's being presented. So again, on the right, we have a multivariable table. Even though it's just one row, there are other variables that are now hidden. And on the left, we have a univariable table. So let's stack them. And you can, again, put some like group headers here. So you can say, these are my unadjusted results, and these are my adjusted results, excuse me. These are my adjusted results down here. So just an illustration of the type of customizations you can do. There's another function, TBL strata. TBL strata, again, works with any gtsummary table. You pass TBL strata a data frame, just like most of the other functions. You tell it what the stratifying variable is, and then you execute some gtsummary code here. Now, you may recognize some of this code from, again, other tidyverse functions. Like we ripped off anything we could take from tidyverse that we thought was cute. And you can see here that using the tilde here initializes an anonymous function. And .x here represents the stratified table. So what's actually going to happen is that TBL strata is going to create 3 different data frames. The first data frame is going to be all the grade 1 patients. The second one's going to be all the grade 2 patients. And the third one's going to be all the grade 3 patients. And then it's going to execute this code inside for each 3 of those data sets. And then at the end, it merged them all together. You can also stack them if you prefer at the end too. So that's just a very simple way to have a bunch of stratified analyses, which is a very common thing that one needs. Any questions before we move on?
I'm sorry, I'm just going to ask again.
Oh, no, Yolanda, please ask every question. I love it.
So when in the previous slide, I think where you had, I guess it was not the previous. Well, yeah, where here that you are making a Cox model with 4 variables, right?
Yeah.
But you're just displaying the treatment one.
Yep.
And you said this is the adjusted. Is there a way to say adjusting for blah, blah, blah?
Yeah. So the modify family of functions, there is a modify footnote function, and you can just say modify footnote, put in this footnote that says this model is adjusted for grade, stage, and marker, and that will appear in your table.
Well, you guys thought of everything.
I mean, I don't know about that, but I've thought of most things that are most helpful for what my job is, and my colleagues, of course. So speaking of things that are helpful for my job, I once got an email from a group of epidemiologists, or maybe they reached out on GitHub or Twitter, I can't recall really. They said, hey, we love the package, but this is a table that we make all the time in the epi world. And I remember making this table in like an intro epi course I took a long time ago, where we had some cases and controls. Were they exposed to our primary exposure, yes or no? And in this case, let's do it by stage. They did a stratified model by stage, so T1, T2, T3, T4. And within each of those T stage levels, they calculate an odds ratio. Then they wanted the crude estimate, which was all of those stages combined into one. And then they take all of these odds ratios, and then they use Cochran-Mantel-Hansel to combine them. This is like, I mean, I know it's common in other fields, but for me, I'm just like, did you just want an adjusted odds ratio? Why don't you just use a logistic regression? But this is before logistic regression existed, and there are still very legitimate reasons to use this method. And so they calculate the Cochran-Mantel-Hansel odds ratio and add a p-value column as well. They said, can you make a TBL CMH for Cochran-Mantel-Hansel? And I said, well, no, I cannot, because if I make your table, I have to maintain your table, and maintenance is actually a huge job. And so, but what I can do is I can show you how to create this table, and let's put it in one of your own packages for your own group. So what we did is we started with orange, with TBL cross, and said, okay, we can actually make a TBL cross that looks just like that. Instead of saying total, we'll change the label to crude. And instead of making it bold, let's make it italicized. And you can do all of this with your typical functions. Then we could use TBL merge to be able to calculate that for controls, and then for cases, and put them together. You could also use TBL strata in that case. Then you can use TBL stack to stack all of those things together. Then you can use addstat to add any custom statistic that you want. And those custom statistics that we decided to add were the univariable odds ratios, or the stratified odds ratios, and then the adjusted Cochran-Mantel-Hansel odds ratio with the p-value. So to be able to construct this table was a shocking minimal amount of code. So being able to cobble together these basic building blocks of far more complex tables is super, super powerful. And it's really a fantastic feature. It's one of my favorite things about the package. It's so easy that my friend Shannon and I, we wrote another package called gtreg, which is like primarily for tables you'll find in regulatory submissions within, like, to the FDA. And so this focuses, I think these examples are primarily about adverse event reporting. So let me just show you what this table looks like. So this may be a common table if you're in this space, where you need to look at the adverse events for one drug versus another drug, and you need to report adverse events by their AE name and by their system organ class as well, which is like this blood and lymphatic systems column. row, excuse me. So now we have a whole nother package that creates something so different from what gtsummary was built to make. And it's super useful for regulatory submissions now. So check out that package as well. If you are in this space, the R in Pharma conference is coming up in a couple weeks, and we're going to be doing a workshop on this package exclusively. Any questions about cobbling things together with stratas and merging and stacking? All right. Themes. So I love themes. I love them so much. The themes are a way that we've built to make incredibly customized tables by just setting one line. So you could, for example, have the Daniel Sjoberg theme, and it changes a lot of the default argument values, but it also can change a lot of things in the package that are actually not available to modify with arguments. So we'll go over a couple of examples here. So this looks very familiar. This is the default theme that you'll see in gtsummary. This is just a simple regression model summary. But if at the top you say gtsummary theme journal, give me the JAMA theme, so a very good journal in the medical field. If you run that and then run the exact same code, you get a bunch of differences here. So primarily, where previously the odds ratio and the confidence interval were in 2 separate columns, now they're in 1. Previously, the confidence interval wasn't bounded in parentheses, but now it is. And rather than a comma between the upper and lower bound, they like to have the word 2. Another thing you might notice is that the p-values, large p-values, were typically rounded to 1 decimal place, and now it's to 2 decimal places as dictated by the JAMA's reporting guidelines. So we have themes for the Lancet, New England Journals, some, a couple of others. And so like if you're publishing in a field that requires like a bunch of like these kind of small changes, definitely hit me up on GitHub and we can collaborate and add your journal's themes as well. There are themes to report results in, I think, 13 languages. Should we count them? 1, 2, 3, 4, 5, 16 languages. So that's pretty fantastic. If you speak a language that's not listed here, also hit me up on GitHub. Let's add it. So here we are looking at the Chinese characters for reporting the exact same table. And again, you just get this by just specifying this theme gtsummary language and then picking your language up on top. So ZH is Chinese and TW is Taiwan for traditional characters versus simplified characters. One of my favorite themes is the compact theme. It's actually part of my custom Sjoberg theme that I have. And I think that the default padding in the GT package is really fantastic when I'm looking at one single table. But when I make a document with a lot of tables, the tables actually become like pretty large relative to everything else. So I want everything smaller. So you can see here the font size is reduced and the padding on both the top and the bottoms of the cells is greatly reduced. And again, you can write your own themes. Check out this vignette on writing your own themes. There are like hundreds of things you can change in a theme. All right, and now we're getting to print engines. How are we doing on time? Oh, okay, not bad, not bad.
Not bad at all.
Print engine. So I did touch on this a bit earlier. So gtsummary written for the GT package. Their tables are gorgeous. I love it. If you don't know Rich Ianin, he maintains and wrote the package GT. He works for RStudio/Posit. He is an amazing programmer and developer. And I just love everything about it. And this slide is out of date. I apologize. So PDF is now fully supported. RTF is almost 100% reported. They just have one little small bug with indentation, and Word is almost entirely supported as well. But if you're using Markdown syntax to bold headers, they have a bit of an encoding issue there too. So like they're so close, and I think that like in the next release of GT, all 4 of these output formats will be supported. But if you're in a rush, it doesn't matter because one of the other engines will work for you. So like for many years, whenever I needed flex table, whenever I needed word output, I always used flex table. Whenever I needed PDF, I was going to Huxtable. We also have via Huxtable an engine to go directly to Excel, for example. Cable Extra is very popular for PDF as well. Cable is nice, but Cable doesn't have like all the full features, like no footnotes. It doesn't do spanning headers. It doesn't indent. So that's why it kind of gets like that little like face. Whereas those joyful green faces look a little bit nicer, I think. So each one of these functions, you can see it has an associated function for GT. It has as GT for flex table, as flex table. So what you can do is you can actually convert any GT summary table to a GT table, to a flex table, to a Hux table, to a cable extra table. And once you've done that conversion, you can use any of the functions from those packages to continue styling your table. So you really can get exactly what you want. So in this very simple case, I am over here converting my TBL summary table to a GT table. Then I'm using these GT functions, calls width, to specify the exact width of my table. And I'm changing the alignment from the default centering to left alignment. Now, if you're not familiar with the GT package, it is phenomenal and amazing, and it can do so much. It exports more than 100 functions just for styling tables. You can get any table you want using GT. So it's super powerful to have these various print engines available to us from gtsummary. So in closing, check out the website. It's super cute. You know, I mentioned that we have a lot of downloads. Like we have like hundreds of thousands, or 300,000 at the moment, or the last time this was run, I'm not exactly sure. So I think you can be pretty confident that the results are accurate with your 300,000 closest friends using the package as well. We have another package with my department at the hospital called Beast Fun for biostatistics functions. And it's kind of used as a sandbox for gtsummary functions sometimes. So things can sometimes start there, then get migrated to gtsummary, or they might just live there as like a little helper function that makes other types of gtsummary functions. So you can see here that this top example on the right, you can add like a column of histograms, which are adorable. The one below that, you can add, you know, spark lines or forest plots to your regression models. If you do a lot of like Likert data, we have a TBL Likert that's a wrapper for TBL summary that's just specifically formatted for Likert data. So quite a few other examples as well. So there are a lot of wonderful contributors to this package. So the primary authors and contributors on the left, and everyone else is on the right. So it's like a lot of people have made this package amazing over the last few years. And so big thank you to everyone who's worked on it. And that's all. So we're going to close with this cute GIF of making tables. So, and if you have questions, please reach out on Stack Overflow. I have like a Slack channel that will automatically show me you have questions posted if you use the gtsummary tag. There's already hundreds of questions that have been answered there as well, so you can go there as a wonderful resource to find answers to your questions too. Is there anything you guys would talk about tables? Yolanda?
This is wonderful. Thank you.
Oh, thank you very much. So I hope that this can be helpful for you. And again, like really the goal here is to be entirely reproducible, that you never have to futz with your tables after you create them. That's one of the biggest, most annoying thing, is to like create some tables, then copy them into a report and be like, oh, now I'm going to just modify the widths of the column, and I'm going to do this, I'm going to do that. Like, I hate that stuff. I refuse to do it now, and it's been wonderful.
I have a question, if that's okay.
Yes.
I'm curious of your experience using the tables you produce from this package in academic publishing. Have you submitted papers with it and gotten good feedback on like its stylization and clarity, or do you use something different for that? And this is just more for presentations. Like, how do you use your
Yeah.
tables?
So the tables I create with gtsummary go directly into published papers. So I was formerly many years on the board for a journal called European Urology, and I wrote the reporting guidelines that are now have been adopted at that journal, and so we built the defaults in gtsummary to follow the guidelines for the European Urology. So European Urology is like the top journal in urology. And since we wrote those guidelines, those guidelines have been adopted by the other 4 top journals in that field. So while I work primarily in urology, you may be thinking like, I don't care about urology. These tables are by default, they look exactly like they'll look directly in the publications. The only difference you'll see is that the journal editors, or copy editors, I should say, they will add like row striping that match their journal. So, but I never found that I really had to futz with that, because every journal will just take the table you've made and like add a bit of color, usually with their default coloring. But yeah, they go straight into the journals. One thing I have noticed that as a part of my job, we do a lot of didactic research with fellows who are on their training years. So these are physicians during their fellowship who have 1 year dedicated to research, and we guide them and help them do good research. The gtsummary package has made things that sometimes maybe a little bit too easy. So there are these fellows who really have no idea what they're doing, creating all of these analyses, and it's like, whoa, stop. Everything you're doing is wrong. So that's the only thing that's the only downside, I think, from having such a package with such an easy API, is that anyone can learn, and also anyone can learn. So it's a little double-edged sword there.
Thank you so much. Yeah, I think just my experience with academic papers and publishing tables, it's often a lot of like little tweaks, like, oh, we use a different font, or oh, this and that. And it's
Oh
good.
yeah.
Yeah, it's good to see a lot of customization within the table that can accommodate some different journals.
Yeah, I've never had a journal come back to me and say change the font, because I feel like their copy editors will just do that. But if they did, oh, I would be so annoyed. To say like, you have one job, it's to copy edit, just do it.
Oh,
Like,
yeah. Yes. Thank you. That was a great answer to that question.
thanks.
Daniel, do you wanna, we can pause or stop the recording, and do you wanna take some time to do some exercises, or how are you feeling?
Yeah, I think we can do. I was thinking that, we are running a little short on time, and the presentation was a little long and a little bit fast. So maybe we, instead of going through the exercises together, what we can go through the solutions to the exercises to kind of just see how something like this might appear in, let's see. Sorry, I have all this Zoom stuff that I can't actually see the address bar. I'm trying to get to a different part of the website. So why don't we just go through, we'll just slowly go through the solutions to the exercises. So this is the website for the workshop, by the way. So the slides we just reviewed, they're all here. There's a recording of it here, and then the exercises are here. You can get them from a download if you prefer that. All the solutions are hosted here. So does anyone need a break before we jump into solutions? I mean, into exercises?
Not me.
Okay. All right, let's just do it. Let's just do it, people. All right, so in these exercises, we're going to be using one data frame from the National Health and Nutrition Examination Survey. And we're going to be doing a couple things. We're going to just assign labels to our data frame, because that's a very important first step. We are going to summarize the data frame. And then we're going to do a little bit of modeling. We're going to do a little bit of modeling in TVL summary, and then also with regression models. So let's get started. Oh, I also see that my computer's about to die. Let me plug it in. Okay, so I recommend to follow along if you can at home with your own R Markdown documents opened, but we're probably go a little bit fast to do that all together. So let's first start by using the NHEFS data set from the causal data package. We're going to select just a couple of variables that we need here. Should I make this larger, by the way?
I can see it fine.
Okay. We're going to select a couple variables that we need here. Our primary outcome is going to be death, a binary endpoint. To keep things easy, we're just going to drop all missing values. So I know that's not normal, but it's easy. We're going to take the variables like quit smoking. So here our exposure is, did the participant quit smoking, yes or no? That's what we're going to do. So they quit or they did not quit. And so we're just going to assign these variables as factors. So they came as 0, 1 numeric variables, but I think when doing summary tables, it's nicer to have labeled factors so that the labels appear in the tables and it's very clear what's going on. So we'll do the same for sex, the same for exercise, and then we're going to use this labeled labeled package and the function set variable labels to assign labels to the column death, participant passed away, quit smoking, participant age, sex, their systolic and diastolic blood pressure, and how much they exercise. Do a quick skimmer of the results. I love skimmer for giving like a super quick overview of what your data, not something you would publish in a journal, but super helpful as a programmer, I feel. So you can see here, you get your continuous variables down, your numeric variables down here. They look cute. You get this nice little cute histogram, little sparkline histogram. So that was the entire exercise 1, is just to import the data and give it a label. So easy enough. Exercise 2 was to prepare a table describing the cohort by whether or not the participant quit smoking. Do not include death in the summary table because that's the outcome of our study. And consider using gtsummary functions that build on a summary table. So we're going to take our gorgeously formatted DF NHEFS dataset that we just created. We're going to pass that or pipe that to TBL summary. We want to see our results by quit smoking or not. And we want to exclude death. So we mostly saw examples of using include to say only include these ones. But like I said, this is tidy select compatible. So you can use the minus sign to say, pick everything except for death with syntax with a minus sign in front. We are going to use add p to make a comparison between the participants who quit and did not quit. We're going to use add stat label to add the statistic labels. And we're going to use modify spanning header to give a cute header called smoking status. And we're going to print that table. So here is our gorgeous summary table, so easy to create and ready to be published. Exercise 3, is there a difference in death rate by smoking status? So as a hint to those doing the exercises live in the workshop, I said, go to this website and it will list all the tests. So I'm going to quickly go there with you. And the reason I wanted to do is that because I want to show you one thing that I think is super fantastic about the package. So like I said before, sometimes I get a little bit nervous about packages that do statistics for me because I want to make sure that they're doing things exactly the way I think they should be done. And this help file lists all the tests that are available for ADP in TBL summary, TBL survey summary, TBL surfit, TBL continuous, and then also the add difference variants as well. So you can see here that if you specify, I want a t-test, it gives you the pseudocode for exactly what's happening in the background. So this is super helpful to confirm that, okay, yeah, that function is actually calculating p-values and t-statistics like I think that they should be calculated. So we have ANOVA, Kruskal-Wallis, Wilcox, chi-square, a chi-square with no correction for ties, or continuity correction, pardon me, Fisher's exact, McNamara for paired data, another variant of McNamara if your data is coming in a wide format, LME4 for random intercept logistic regression models. So that's very nice when you have correlated data, like multiple observations per patient. We have paired t-tests for when your data are paired Wilcoxon, proportion tests, other ANCOVA, and then EM means is super, super helpful. If you haven't heard the EM means package, it's pretty awesome and you should read up on it. I love it. And so I just want to show you that briefly. So this help file is super helpful, I think. That's why the word help is in the title, I guess. So it says, is there a difference in death rates by smoking status? So here's a table, all right? We took our data set, we passed it to TBL summary. We said, give us some summary statistics by quitting status, include only death, because I am only reporting the outcome here. I want to report just the rate of death. I don't want the N in percent in this case. And I'm doing add difference and add stat label. What are some good things and bad things about this table? Like, is this a final analysis for the study question? Does quitting smoking reduce death rates? I would say it's not a great answer to that question. It's a good start, but I would say simply because, well, what are the differences between people who smoke and who quit smoking and those who didn't? So let's go back up to our table. So we can see that, okay, this is actually the opposite of what I would have thought. People who quit were older than patients who didn't quit. I kind of would have thought, oh, I've been smoking my whole life, I'm not going to bother with quitting. Something like that. You can see there are differences in sex, there's differences in their blood pressure. So that we know there are differences between these two groups. So this gives a great univariate solution to that question, but oftentimes we need to control for other confounding variables. Now, if you are a trained epidemiologist or statistician, please no comments on whether or not these are actual confounding variables versus colliders versus whatever, because there's a lot of correlated things going on here, and the diagrams are not like super nice, like the triangle of confounding, like you may have learned in Epi 101. So we're just going to pretend everything's like a simple confounder here. So let's do this again, but let's adjust the rates. So here we start out exactly the same. We go to add difference, and this time I'm going to say I'm going to use EM means instead. All right, and I need all of these models adjusted for age, sex, systolic and diastolic blood pressure, and how much that person exercises. So these are the differences that I'm making right here. So what is actually happening in the background is that it's building a logistic regression model with treatment, with whether or not the participant quit smoking as the primary covariate, adjusted for all those other things. So it's building all of this in the background, and you can see this in the help file to show what is actually happening. And then it's going to give you a least squares mean estimator, or the EM means estimator of that difference in rates. And that's what we're getting here. So the adjusted rate is 1.1%, whereas previously we saw that it was almost 5%, right? In the opposite direction. So that's actually a huge migration of an estimate when you adjust for confounders, which are not really confounders, but it's okay, because things like smoking certainly affect your blood pressure and that kind of thing. But anyway, I just really wanted to highlight here that you can do pretty complex analyses with the add difference function. And this would work for continuous variables, and in this case, a dichotomous variable as well. Exercise 4, build a logistic regression model with death as the outcome, include smoking and the other variables as covariates, and summarize your regression model in a table, reporting the odds ratio, confidence interval, and p-values. So this is probably a far more typical way that you would see this kind of question addressed in the medical literature, at least. We build a regression model that includes smoking yes or no as a covariate, and we adjust it for a bunch of other things that we know are different between the two groups. So we take that logistic regression model called MOD, we put it into TBL regression. We say we're going to exponentiate those coefficients to get odds ratios. And we're going to use a couple cute little functions here. We're going to use add global p, which you saw previously, which is going to move p-values from levels of a categorical variable to global p for that whole variable. And we're going to bold significant p-values. We're going to italicize levels. We're going to change the caption of the entire table. And we're going to modify the header to say, instead of saying characteristic, it's going to say variable. And then it's also going to report the n. So please do read the help file for modify header. There's a lot of dynamic variables that you can, or values that you can add to the table in these curly brackets. So when it sees those curly brackets, it's going to go and add the n from the model here. And so you get this lovely table. Logistic regression model predicting death. Includes 1,500 patients. So there you go. Looks great. Any questions on these tables that we've built so far?
So earlier, Wendy did have a question in the chat. I think she tried to run, it wasn't this specific table. I think it was table UV serve maybe, or MV serve, and she had some errors. So we can also wait till the end to check that out. But
okay, yeah, let me
did you find it in the chat?
I didn't see it in the chat.
Okay, I'm gonna copy it and paste that. Wendy,
Okay.
are you on? Did you wanna? You can also.
Well, there's
Feel free
only
to-
one more exercise, so let's just get to the last
Yeah,
one, and
yeah.
then we will chat about that.
Sounds great.
So the last thing was to write a brief summary of the results using inline text and markdown. So whenever I do this, I like to make an object that has kind of a long descriptive name. And I like to define all of those up in a hidden R code chunk that appears above my text. But when you render, because it's hidden, you won't see any of this code. And I'm using the patient characteristics table and to report the variable age. I want to find the median age for those who quit. Next, I want the median age for those who did not quit. And I want the p-value comparing the ages for those who did and did not quit. I want the unadjusted difference that we calculated in death rates by the treatment, by the two groups for smoking and did not smoke and quit smoking. And then lastly, I'm going to report the odds ratio, my adjusted odds ratio from my logistic regression model table. So you can see here that sometimes we're changing up the pattern. You can see you can add just plain text here, odds ratio, bam, confidence interval this. So in this case, I'm reporting the p-value. In this case, I'm not reporting the p-value because you can just report whatever you want. And if you look at the raw file in the exercises, you can see the raw code here, but essentially it's a bunch of text and it says we're including 1,548 patients. We took that from the model as well. The median age among those who quit was higher compared to who did not quit, a median of 46 versus 42, and here's our p-value comparing them. On univariate analysis, participants who did not quit smoking had higher rates of death difference, negative 4.9%, confidence interval p-value. And however, on multivariable analysis, the relationship was no longer significant. Here's my odds ratio. Here's my confidence interval. So there we are. That is the world's shortest report on a very poorly designed study by me. But I think it illustrates the concepts pretty well, I would say. Okay. So was there a question?
Yeah, I'll go ahead and stop the recording, but thank you so much, Daniel. I'm gonna stop this right now and we'll go over some questions.